Okay, so these are graphing problems. This is your green worksheet. So I want to go through some of these, refresh your brains. Remember, inside of here, backwards of those is always going to be the center. Okay, so that's the center of this. This is an ellipse because these are different numbers down here. A circle would be the same numbers and it would be over here. So since this is an ellipse, this is always going to be the center backwards of those. So this is the x value because it's with the x. This is the y value because it's with the y. So I go -3, 4, put a dot there. That's the center. So then now I need to figure out how far I go from the center in each direction. So to do that, I take the square root of this number. So the square root of 25 is 5, and that's under the x. So that means in the x direction, I go 5, 1, 2, 3, 4, 5, each way from the center. The y value, the square root of 36, is 6, so I go 6 each direction from the center. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now I connect those. And it's supposed to look like an ellipse. Not my best picture ever, but you get the general idea. Okay? So anyways, that's the ellipse for the first question. Question number 2. Now these two, like question 1, had divide. This one doesn't have any divide on it, and it has some number over here, not a 1. That's a circle. Okay, again, backwards of these in here is going to be the center. So the center for the x is 2, the y value is -1. So I come to my graph, I put a dot at 2, -1. Now, the radius, this is always the radius squared that's given right here. So to get the radius, I take the square root of it to get rid of the squared. So I get the radius is 4. So from that center, I go 4 in each direction. So I go 4 up, 4 down, 4 to the right, and 4 to the left. And now you're supposed to make it look like a circle. As good as you can. Hopefully they look more like circles and not like a square. Anyway, that's a circle. We'll pretend that it's a circle. Okay, the next one. This is an absolute value. Oh, going back to this one. It says less than. So that should be dotted. Should be dotted because it's a less than. Okay, so less than means you shade inside. There we go, that's better. All right, question number 3. This is an absolute value. Again, this is the same thing in here. -3, +2. Not +2, hold on. So inside the parentheses or absolute values or whatever it is, always backwards. Out here is the same. So the vertex of this absolute value, remember absolute values are always these. This point right here is at -3, -2. So I come to my graph, -3, -2. There it is. Now the slope is this number out here. So I go up 1 over 2, up 1 over 2, up 1 over 2. I can do this forever. And because it is a less than, it's going to be a dotted line. Now because it's less than, I would shade everything below. So less than is everything shaded below. I shade all of this stuff down below. There's that part. Now the next part's that ellipse again. So the center is going to be at -3. The y value is 1. So that's the center of the ellipse. So x is negative 3, y value is 1. Now in the x direction, it's the square root of 16, which is 4. In the y direction, it's the square root of 4, which is 2. So in the x direction, I need to go 4, 1, 2, 3, 4. Put a dot, 4 to the right, 2 up, 2 down. Less than means the lines are dotted. And since it's less than, it's shaded on the inside. So the only place where they intersect is in this area. So that's my answer. Okay, that was question 3. Question number 4. This is a parabola. You can graph it on your calculator. Again, the vertex of this is going to be opposite of that, so it's going to be 3, 5. And this is negative, so it's going to open downwards. So I'd come over here, 3, 5, put a dot. You can go to your calculator if it makes you more happy to do it that way. Type it in. On yours you can do the less than, on mine I can't, so I just know it's going to be shaded below and it's going to be a dotted line. So I'm going to go parentheses, or negative, parentheses, x minus 3 quantity squared plus 5, second graph. I'm looking for the center where these like are the same above and below, so there's 3, 5, which I already knew was the vertex. Then it goes 2, 4, 1, 1. So 2, 4, 1, 1, 0, negative 5, negative 4. And then it's just the mirror opposite over here. These are dotted lines. And it's shaded below, so it's less than. So less than shaded below. This keeps going on forever and ever and ever and ever. So anyways, that's my parabola. But now we have a circle, because they're both squared. So backwards of those, whoops, 3, 2. So I come over here, 3, 2, put a dot. And the square root of 9 is 3, so I go 3 in each direction. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It's less than or equal to, so it can be a solid circle. So I'll make it look nice. Use my cheating tool. Come on. And because it's less than, it's also shaded on the inside. Whoops. I don't want to do that. That would fill it all in. So the only place where these two intersect is right in here. So that's my answer. All right, on the back page, system of equations, there's 3 of them now. Okay, so I'm going to start off by solving for z, because it says 3z equals 15, so I divide it by 3. 15 divided by 3 is 5. Now I come into this second equation, and I'm going to plug, 4 times 5, because I plugged 5 in for z. So I have 2y plus 20 equals 4, minus the 20 over. 2y equals negative 16, divided by 2, and y equals negative 8. So I have z, I have y, I need to get x. So I have 3x minus y, which is a negative 8, plus z, which is 5. So when I have negative numbers, I normally put them in with parentheses, just so I can remember the sign that goes with it. So now I see minus a minus turns that into a plus 8. So 8 plus 5 makes 13. So now I can minus 13 from each side. 22 minus 13 is 9, so I divide it by 3, and x equals 3. So I get 3, negative 8, so x, y, z. Question 2 is more challenging because it has x's, y's, and z's. So when you're doing these kinds of problems, you have to eliminate a variable, the same variable, using 2 of them, and then the one that didn't get used, and one of these ones before. Okay, so I'll show you how that's done. I pick a variable first of all. I could get rid of x, y's, or z's. I see these y's are the same, so I'm going to combine these two equations first of all. So I write those two equations down, and I combine them. And the y's go away. Okay, so I've got rid of the y's, but now I need to use this third equation that hasn't been used so far. And I want to combine it with one of the others to get rid of the same variable, which is y. So I look at this and I say, man, these are not going to go away if I add them together right now. So I'm going to write them down. So these are the two that I'm working with. And I want to get rid of the y. So I see that 3 and 2 are here. I know that both 3 and 2 go into 6. So I'm going to multiply this one by 2 and this one by negative 3. I need one of them to be negative. It doesn't matter which one. So 2 times 2x makes 4x. 2 times 3 makes 6, and there's still the y. 2 times negative z makes negative 2z. And 2 times 12 makes 24. Negative 3 times 3 is negative 9. Negative 3 times 2 is negative 6. And negative 3 times 2 is still a negative 6, but it's a z now. Negative 3 times a negative 4 is 12. I check my signs. Those were all positive except for the negative, so now they're all negative except for the positive at the end. So now when I combine them, I get negative 5x. The y's go away, which is what I wanted, because the y's went away on this one. I want the same variable to disappear. Okay, so now I have negative 8z equals 36. So now I have a blue equation and a green equation. And now it's the same thing as what you've done before. You're going to solve for x or z from these two equations. So I have to decide, do I want to get rid of my z's or do I want to get rid of my x's? The smallest number both z's go into is 40. The smallest number both the x's go into is 20. So I'm going to get rid of my x's. So I'm going to multiply this one all by 5 and this one all by 4. So 5 times 4 is 20. 5 times 5 is 25 z. And 26 times 5, negative 26 times 5 is negative 130. Now on the bottom, 4 times negative 5 is negative 20. 4 times negative 8 is negative 32z. And 4 times 36 is 144. So 32 minus 25 is 7, and it's negative because there's more negative 32s. And 144 minus 130 is 14. So now I divide it by negative 7, and I get that z equals negative 2. So now what I've got to do with this z equals negative 2 is I've got to plug it into either the blue one or the green one. It doesn't matter which one. So I'm going to plug it into the blue one and solve for x. Okay, so I'm going to take my blue equation, 4x plus 5 times z, which we just discovered that z is negative 2. So I plugged that in, equals negative 26. So 4x minus 10 equals negative 26. So I add 10, I add 10. So 4x equals negative 16. Divide it by 4, and x equals negative 4. So now I need to find out what y equals. So to do that, I plug it into one of these purple equations. It does not matter which one. You pick any purple one you want. So I'm going to pick the top one. So 2 times x, which we just discovered x is negative 4. Plus 3y minus z, which we found out is negative 2, equals 12. So I've used this top equation and I've replaced x and z into here. So 2 times negative 4 is negative 8, plus 3y plus 2, because a negative and a negative make a positive, equal 12. Negative 8 plus 2 is negative 6, plus 3y equals 12, so I add 6 to each side. So 3y equals 18. So divide it by 3, and I get that y equals 6. So that's how we do 3 equations, 3 unknowns. We take any 2 equations, we get rid of a variable, so we got rid of y. Now I take the third equation, and either of these 2 that have been used before, and I use that equation to get rid of the same variable. Okay, so that's the green part that we did. I used the top one and the middle one, and I got rid of the y's. Okay, so then I have 2 equations, the blue one and the green one, that had only 2 variables. So I used those 2 equations, turned into the red, and we got rid of the x's. And then we could solve for z. Once you get a z, you plug that number back in to one of the 2 equations that only have 2 variables, the x and the z. So I plug the z back in, and we solve for the x's. Once I get x and z, I plug those 2 variables back into any one of these equations, and I solve for y. So now let's try another one of those. Maybe. All right, so here's the last one. I can get rid of the y's, I could get rid of the z's, or I could get rid of the x's. Either way, it doesn't matter. I'm going to get rid of these x's. So I'm going to combine the purple one and the yellow one together. So the yellow one is negative x minus 2y plus 10z equals negative 11. And the purple one is x plus, that didn't show up, x plus 3y minus 5z equals negative 12. So I add those together, and the x's go away. So let's make that light green. Hopefully it shows up. 3 minus 2 is 1. 10 minus 5 is 5. And negative 12 and negative 11 make negative 23. So the x's went away. But now I have this blue equation. I have 2x minus 4y minus 5z equals 47. And I need to get rid of the x from it. So I've got to use either the purple or the yellow one. I'm going to use the yellow one because it already has a negative with that x. Okay, so here's the yellow one. So these are the 2 equations I'm going to work with. But I'm going to multiply this yellow one all by 2. So I now have negative 2x minus 4y plus 20z equals negative 22. So negative 2, negative 4, positive 20, negative 22. So I just go through and I hurry and check my work, make sure I haven't written stuff down. And the blue one hasn't changed. wrote it down. 2x minus 4y minus 5z equals 47. So now when I combine these, let's write our combined answer in white. The x's go away. Negative 4y and negative 4y do not go away. They're both negative, so they combine to make a negative 8y. 20 minus 5 is 15, and 47 minus 22 is 25. So now I have the green equation and the white equation. So I'm going to just write them together so you can see them. I write those two equations together. Now I see that my y's won't go away and my z's won't go away. So I am going to multiply all of this by either by 8 or by negative 3. So I choose negative 3. It's a smaller number to multiply by. So I get negative 3y minus 15z and a positive 69. So when we combine those, we get negative 11y. The z's go away. 5 plus 9 is 4. Carry the 1. 394. That's not good. It's supposed to be a nice fraction or something. So hold on while I try to figure out my mistake. So I found my mistake. My mistake was right here. This negative 11 is supposed to be a 6. So hopefully I remember to tell you this before I give you the paper, because that has a change on everything. So that should be negative 6, which makes 3 times negative 6 is a positive 18. So now it's still not working out. Hold on. Okay, so I messed up. I reworked my work or my problem. Right here's where I had the mistake. I had that as a negative, so that was a 25. So it's actually a positive. So now when I rewrite it over here with the green one, so I'm going to multiply that green one all by 3. So 3 times the green one. So that makes 3y plus 15z equals negative 18. The black one's still the same. Negative 8y plus 15z equals 59. So if I add those together, nothing goes away. So I really should multiply by negative 3. So that needs to be negative, negative, positive. So now those go away. That makes negative 11y, which is what I had before, but that's a positive 18. So that makes 7. Carry the 1, that makes 77. So divide by negative 11, and y equals negative 7. So now I can plug that into my green one or the black one. I'm going to plug it back into the green one. So I have negative 7 plus 5z equals negative 6. So now I add the 7 to each side. So I have 5z equals 1. Divide it by 5, and z equals 1/5. So now I just need to get x, so I'm going to plug that into the purple one. So I have x plus 3y, which is negative 7, minus 5z, which is 1/5, equals negative 12. So x minus 21, the fifth of negative 5 is negative 1, equals negative 12. X minus 22 equals negative 12. Add the 22 over, and x equals 10. So those are your 3 answers, x, y, and z, and that's how you do a system of 3 equations.